Today, we're not just tackling a big topic, we are tackling the biggest one of all. We're opening the ultimate cold case file, the origin of everything. You know, for as long as humans have been around, we've looked up at the night sky and asked that very question. It's this deep, fundamental mystery that connects every single one of us to our ancestors who gazed at those same stars and just wondered, where did all this come from? All right, let's get into it. Our cosmic detective story is going to unfold in 4 main chapters. First, we'll look at how we figured out our place in the cosmos. Then, we'll check out some of the early theories about how planets formed. After that, we hit the huge breakthrough moment. And finally, we'll zoom right in on how our own cosmic neighborhood got built. So any good investigation has to start with a map, right? But for most of human history, our map of the universe was, well, let's just say it was completely wrong. Our story really begins with those first attempts to chart the heavens and figure out where we fit into the whole picture. For over 1,400 years, one idea completely dominated everything: the geocentric model. An astronomer named Ptolemy put Earth at the absolute center of the universe, and that was that. But, new evidence started to creep in. In 1543, Nicolaus Copernicus dropped a bombshell of a theory, the heliocentric model, which put the sun in the middle. It was a brilliant idea, but he didn't really have the hard proof. That had to wait for Galileo Galilei. Armed with this brand new invention, the telescope, Galileo pointed it up and saw things nobody had ever seen before. He saw moons orbiting Jupiter and Venus going through phases, just like our moon does. And that was the smoking gun. It only made sense if all the planets, including our own, were orbiting the sun. In that moment, our entire perspective shifted. So once we had the map right, a new mystery popped up. Okay, if Earth and the other planets orbit the sun, how did this whole system get here in the first place? It was time to round up the cosmic suspects. The first major theory on the scene was the nebular hypothesis, dreamed up back in the 18th century. The idea was actually pretty simple and elegant. Our entire solar system started out as this massive, slowly spinning cloud of gas and dust, mostly hydrogen and helium. These giant cosmic nurseries are called nebulas, and we can actually still see them out there today making brand new stars. And what's really cool is how you can see it happen here. Gravity just starts pulling this huge cloud inward, and as it collapses, it spins faster and flattens out, kind of like a figure skater pulling their arms in to spin faster. Almost all of the material gets sucked into the center, getting so hot and dense that it bursts into life as a star, our sun, and all the leftover stuff forms this flat spinning disk around it. But hey, a good detective has to poke holes in every story, right? And this one had a couple of big ones. First, there was this thing called the angular momentum problem. Think about that figure skater again. The center should be spinning the fastest. But in our solar system, it's the exact opposite. The planets, which have barely any of the total mass, somehow have 98% of the spin. The sun, with almost all the mass, is just slowly rotating. That just didn't add up. Plus, scientists weren't sure the disk of dust had enough stuff in it for gravity to really grab hold and form planets. The case was definitely not closed. So a new suspect was brought in. The gaseous tidal theory. This one was way more dramatic. It imagined that our sun, which had already formed, had a super close call with another huge star that was just wandering through the galaxy. And this illustration just nails the idea. As this visiting star zipped by, its incredible gravity would have acted like a giant cosmic magnet, literally tearing a long, cigar-shaped stream of hot gas right off the surface of our sun. Then, as this stream of material was left behind, it would have started to cool and clump together, eventually forming the planets. Okay, now we get to the breakthrough moment. All these early theories were just focused on our little solar system. But in the early 20th century, the investigation went from being a local case to a universal one. And one single discovery changed absolutely everything. The detective who cracked this whole case wide open was an astronomer named Edwin Hubble. Back in the 1920s, he noticed something staggering. Almost every distant galaxy he could see was flying away from us, and the farther away they were, the faster they were going. Now, this wasn't like an explosion where everything flies out from the middle. No, the very fabric of space itself was stretching. Think about drawing dots in a balloon. As you blow it up, every dot moves away from every other dot. That's what Hubble saw happening with the galaxies. The universe was expanding. So if the universe is getting bigger today, that means yesterday it was smaller. And the day before that, it was even smaller. If you rewind that cosmic clock all the way back, about 13.8 billion years, everything, and I mean everything, all matter, energy, space, and even time itself, had to have been squeezed into a single point of insane density and heat. We call this point a singularity. It's a place where physics as we know it just breaks down. The Big Bang Theory says our universe started not as an explosion in space, but as the rapid expansion of space from this one hot, dense starting point. This timeline is just incredible. Right at the very beginning, in a teeny tiny fraction of a second, the universe inflated, expanding faster than the speed of light. Right after that, it was the super hot, chaotic soup of tiny particles. Then, within the first few minutes, as things cooled down, those particles started to team up to form the first atomic nuclei. But it was still this thick, foggy plasma. Light couldn't get through. It wasn't until about 380,000 years later that the universe cooled down enough for the first stable atoms to form. That moment was huge. It was the first time light could travel freely, creating this cosmic afterglow that we can actually still detect today. So, how in the world do we know all this? Well, the key piece of evidence is called redshift. Think about an ambulance siren. As it comes towards you, the pitch is high, and as it goes away, the pitch drops low. Light does the same kind of thing. Light from something moving away from us gets stretched out, shifting it toward the red end of the spectrum. That's redshift. And light from something moving toward us gets squished, shifting it to the blue end. When Hubble looked out at all those distant galaxies, he saw they were almost all redshifted. That was the smoking gun. The universe really is expanding. This simple sentence from Edwin Hubble is honestly one of the most profound discoveries in all of human history. It's the foundation of all modern cosmology. He's the one who gave us the evidence that completely rewrote our story of the universe, from a static, unchanging thing to a dynamic, evolving story that had a beginning. So now we've got the grand origin story for the whole universe. The Big Bang made the raw materials, hydrogen and helium. So let's zoom back in from that cosmic scale and see how those materials got assembled into our own home, the solar system. And here it is, the finished product of that whole messy, chaotic construction job, our solar system. You can see the sun there in the middle, the 8 planets and their nice stable orbits, and that clear dividing line, the asteroid belt that separates the inner planets from the outer giants. And way out past Neptune, you've got the Kuiper belt, home to places like Pluto. So there you have it. The cosmic detective story has taken us all the way from an impossibly tiny point of pure energy to this vast, expanding universe filled with billions and billions of galaxies. It's a journey across 13.8 billion years of cosmic history. But you know, like any great detective story, Solving one mystery just opens up another, even deeper one. Our science can take us back to a fraction of a second after the Big Bang, but it totally breaks down at the singularity itself. The question of what came before the beginning, or what even caused it, that remains the single greatest unsolved case in all of science. It's a mystery that leaves us right back where we started, looking up at the sky and just wondering.